Here I have a question that says points A and B have coordinates h, h and 4h plus 6, 5h. And the equation of the perpendicular bisector of AB is 3x plus 2y is equal to k. And I need to find the values of the constants h and k. So here it's told that there is some point A that has the coordinates of h, h and point B that has the coordinates of 4h plus 6, 5h. And let's say that point A is somewhere over here and point B is over here. A and B form a line and there is a perpendicular bisector to this line. Remember, the perpendicular bisector passes through the midpoint of the line. So the perpendicular bisector is going to look like this. This is the perpendicular bisector and we are told that the equation of the perpendicular bisector is 3x plus 2y is equal to k. So 3x plus 2y is equal to k. And I need to find the values of h and k, where the coordinates of A are h, h and coordinates of B are 4h plus 6, 5h. Now the first thing I'm going to do over here is I'm going to find the gradient of this white line. We know that the gradient, which is m, is equal to y2 minus y1 divided by x2 minus x1. Let's name this point as x1, y1 and this as x2, y2. So this would be equal to 5h minus h divided by 4h plus 6 minus h. So 4h plus 6 minus h. 5h minus h is 4h and 4h plus 6 minus h is 3h plus 6. This is the gradient of this white line. So I'm going to name the gradient of the white line as m1. Now I'm going to find the gradient of this perpendicular bisector. I don't know any point on the perpendicular bisector, but I do know the equation of the perpendicular bisector. We know that if we can rearrange the equation in the form of y is equal to mx plus c, we can find the gradient, that is the coefficient of x, by comparing. So if I rearrange this in this form, if I send 3x on the other side, I'll get 2y is equal to minus 3x plus k. And now if I divide both sides by 2, I'll get y is equal to minus 3 upon 2x plus k upon 2. And now you can see that the coefficient of x is minus 3 upon 2. So the value of m2, the gradient of this perpendicular bisector, is minus 3 upon 2. We know that these two lines are perpendicular to each other, meaning that they are intersecting each other at a 90-degree angle. And whenever that's the case, the relationship of the two gradients of the two perpendicular lines is m1 times m2 is equal to -1. We know the value of m1 is 4h divided by 3h plus 6 and m2 is minus 3 upon 2 and is equal to -1. The only unknown in this equation is h, so I can solve this equation for h. I'll get minus 3 times 4h divided by 2 times 3h plus 6 is equal to -1. Now I need to make some space over here, so I'll erase these two steps here. 4 divided by 2 is 2. So I'll get minus 3 times 2h, which is minus 6h divided by 3h plus 6 is equal to -1. Multiplying both sides by 3h plus 6 is going to give me minus 6h is equal to minus times 3h plus 6. These two negative signs cancel each other out and I have 6h is equal to 3h plus 6. Subtracting both sides by 3h would give me 3h is equal to 6, and dividing both sides by 3 would give me the value of h as 6 upon 3, which is 2. So the value of h is 2. Now I have found the value of h. The other thing that I need to find is the value of k. And k is present in the equation of the perpendicular bisector. So I need to find the value of k. I do know the value of h, so I'll put this value of h in my coordinates of a and b, and the coordinates of a that I'll get is 2, 2, and the coordinates of b that I'll get is 4 times 2 plus 6, which is 14, and 5 times h, which is 10. We know that the perpendicular bisector passes through the midpoint of this white line. The midpoint satisfies this white line and also this perpendicular bisector. So let's find the midpoint of this white line. The formula of the midpoint is x1 plus x2 divided by 2, comma y1 plus y2 divided by 2. x1 is 2 and x2 is 14. So this would be 2 plus 14 divided by 2, comma 2 plus 10 divided by 2. This would give me 16 upon 2, comma 12 upon 2. 16 upon 2 is 8 and 12 upon 2 is 6. So the midpoint is 8, comma 6. These are the coordinates of the midpoint, 8, comma 6. And since this perpendicular bisector passes through this point of 8, 6, I can substitute 8, 6 in this equation to find the value of k. The equation of the perpendicular bisector is 3x plus 2y is equal to k. And this line passes through the point of 8, 6. The value of x is 8, so 3 times 8 plus 2 times 6 is equal to k. 3 times 8 is 24 and 2 times 6 is 12 and is equal to k. And this gives me the value of k as 36. So this is the value of k. So this is my answer. H is 2 and k is 36.